Lesson 2.3, polynomial functions of higher degree with modeling. Here we go. First thing we need to do is we need to factor. We're going to need to be factoring a lot with our work here. So the first thing you want to do is factor out a greatest common factor if possible. Now, depending on where you are with how good of a factorer you are, you may need to factor this one by grouping. Remember, you multiply the a times the c, and you're looking for factors that add to negative 11. Product of negative 12, sum of negative 11, which is negative 1 and positive 12. And then I split my negative 11 into negative 1x plus 12x. So all I've done is rearranged the negative 11 into negative 1 plus 12. And then we group, and we group. And we take out an x and have 3x minus 1. And we take out a 4, and we have 3x minus 1. And now we take out a 3x minus 1. And we're left with x plus 4. So this factors into 3x minus 1 and x plus 4. First thing you want to do here is you always want to take out the greatest common factor, which is a 2x, and that leaves me with 2x squared plus 5x minus 12. And now the 2x needs to continue to come along for the ride. And now you could go through the grouping process with this if you need to, or you can recognize that this would 2x squared, the only way to break it up is 2x and an x. And then I'm really looking for, you can use the same tools and think to yourself, negative 24 for positive 5. Well, negative 24 for positive 5 is a positive 8 and a negative 3. So I can make positive 8 and negative 3. You can factor by grouping if you need to, but you can check this out. 2x squared plus 8x minus 3x. There's that 5. And then negative 3 times 4 is 12. So where did the positive 8 go? It's 2 times 4. Again, if you're not comfortable doing it like that, then go through the grouping. Solve each equation on the bottom mentally. Mentally means we're going to set these equal to 0. Notice we just picked these apart. X equals 0, x equals 2. Very quick. Over here, x equals negative 2, x equals negative 1. Down here, x equals 0, x equals negative 3, and x equals 5. Now, this right here technically means that that would be x plus 2 times x plus 2. So really there's 2 of these ones. Look at this. That's x times x times x. Really there's 3 of those. I wonder if that means anything. Cubic functions. If the lead coefficient of a cubic function is positive, we will always go up to the right and down to the left, no matter what the rest of it does. If the lead coefficient of a cubic function is negative, then we will always go up to the left and down to the right. I like to think of these as slope. Y equals mx plus b has power 1, but it's very similar because I either have positive slope or negative slope. And these are very similar to what we're talking about there. When we're talking about quartic or to the power of 4, So this is the lead coefficient of there. Again, very similar to a parabola. Think parabola. If it's positive, it's going up and up. If it's negative, then it's going down and down. Parabola. Y equals ax squared. If the a is positive, it's up. If the a is negative, it's down. That's going to be our end behavior as we head towards, as the x's head towards infinity. Where does the graph go? A polynomial function of degree n, so this is going to be the degree, has at most n minus 1 local extrema. Remember, those are max mins, okay? So if you think about degree 1 has no max or minimums, Degree 2 has 1 max or minimum, and that's 2, the degree is 2 minus 1. Degree 3, and it's at most, so it's the maximum, because they can look a little bit funny. Degree 3 could have 2 humps and bumps. Degree 4 could have 3 humps and bumps. I could be here all day. Degree 5 could have 1, 2, 3, 4 humps and bumps, okay? So you're always going to know your maximum number of humps and bumps is going to be 1 less than the degree. Also, we have at most n zeros. So if I think about putting these things on a coordinate plane, I could have a coordinate plane. Notice I have 1, 0. Degree is 1. I could have a coordinate plane. I have 2 zeros. I could have, at most, the maximum, 1, 2, 3 zeros. I could have 1, 2, 3, 4 zeros. I could have 1, 2, 3, 4, 5 zeros. And that's the maximum number of zeros that any polynomial could have. Okay, the leading coefficient can tell you the end behavior. So if you know that you are odd and positive, you know that you are going to go down to the left and up to the right. So you're going to be able to tell, before you even start, you're going to be able to tell what's going to happen. So notice, the limit as the x's go to the right, the y's, or the function, or the f of x's, go up to positive infinity. As we go out to the left, the y's, or the function, goes down forever to negative infinity. And then this is going to be a lead coefficient. This is odd and negative. And we will always finish up to the left and down to the right. And you can write your end behavior. Your limit notation needs to be written properly. This is even, resembles a parabola. So I like to think this one resembles a cubic when it's odd. This one resembles a parabola when it's even. So this is positive and even, up and up. Think of a ref signaling a touchdown. This is going to be negative and even, down and down. Think about pointing both your fingers towards the ground. These ones, up to the left, up to the right, down to the left, and then we switch. Staying alive, staying alive. Describe the end behavior. The end behavior, the lead term will manage everything, because if you're going to put really big x values in here, this one's going to take over. Really big numbers to the fourth are going to dominate anything squared, dominate this, and this -1 is obsolete. So the only thing we're worried about there is positive and even, which means I'm going to resemble a parabola that opens up, and I can do the limit as x's head towards infinity. As they get really, really big, the function, oh, this is a g of x, will also get really, 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 really big. And then as we head out to the left, my negative infinity, the even power is going to turn everything positive, and that's going to turn the function g of x again, up to positive infinity. And then when we talk about the next one has a, the only thing I'm worried about is this one, because huge numbers cubed dominate these ones and no longer make a difference. So I'm only worried about the fact that it's positive and odd, which means it's going to resemble that. And I'm only worried about the limit as x approaches infinity. The function h of x will head towards infinity, and the limit as x approaches negative infinity, the function h of x will also approach negative infinity. Really big negative numbers raised to the third power will result in really big negative numbers. Find the zeros and sketch the graph without a calculator. So the first thing you're always going to do if you're looking for the zeros is you're going to factor. So I'm going to factor this into, I'm going to take a 2x out, and I'm going to be left with x squared minus 2x minus 3. I'm going to continue factoring because I'm looking for the zeros, so I'm going to set it equal to 0, and I'm going to have what do you multiply together to get negative 3? Add together to get negative 2, negative 3, and positive 1. So I have zeros at 0, 3, and negative 1. My end behavior tells me that I'm positive and odd, which means I will resemble end behavior up to the right and down to the left. We're going to sketch. It's not going to be perfect. I'm going to do the best I can. The first thing I'm going to do is label my zeros at negative 1, 0, and 3. And then I'm going to think about my end behavior. Always think about your end behavior next. And if I'm going up to the right and down to the left, then I can tell what's going to happen here. Through. And that will work itself out each time properly, because it tells me to have a 0 at those 3 spots right there, and it tells me my end behavior. There it is. Good. Multiplicity. I told you back there that it says if we have even multiplicity, we have to pay attention to that because the factor occurs 2 times. 5 is a 0 with multiplicity of 2. So now, if we have an m up here, we have to keep track of the fact that we have a multiplicity. It occurs more than once, and that's going to affect our graph. So we need to take a look at how multiplicity affects our graphing. So the first thing we're going to do is we're going to identify that this one right here has zeros at x equals negative 3, and that's multiplicity 1, or odd multiplicity. And then we have x equals 5, and that's multiplicity 2, or even multiplicity. And then this one has odd multiplicity. So let's look at our grapher and say x plus, clear. Okay, x plus 3 and x minus 5 squared. And when we graph it, we can see that the negative 3, which has odd multiplicity, goes through the x-axis, and then it goes up and comes down, and the 5, which had even multiplicity, touches and bounces off the x-axis. So let's see if we can make a slight change here. And we can see, let's change that to cubed. Now we have odd multiplicity and odd multiplicity. And now we're going through at negative 3 still, but now we're also going through at 5. So that changes things. So the even multiplicity and odd multiplicity is either going to take you, through or it's going to bounce off. So based on what we looked at, if I change x minus 5 to the fourth, I think that's going to bounce off, and it does. So we go back here, and it asks the question, does it go through? So it goes, odd multiplicity goes through the x-axis, even multiplicity touches. So down here, the -3 again goes through the x-axis, and if you think about like y equals x cubed, that goes through the x-axis, where y equals x squared. So the even and odd, you've been dealing with this before, you just didn't know it. So then we had x equals 5, multiplicity of 3, and it touches, or excuse me, that also goes through because it's odd. Holy cow. And then this, whoa, what happened? Where do we go? Where did we go? There we go. This one would be x equals -3, and that would touch because it's got a multiplicity of 4. And this one would also just touch and bounce off, and that has multiplicity of 2. So now it wants us to sketch the graph. And if we did this without a graphing calculator, first of all, the whole thing has degree 3. And then we have, so that means I know I'm going to finish like that, right? And then we know that x equals -2 is a 0, and it has multiplicity of 2, which means that should touch. And then we have x equals 1, and that has multiplicity of 1, which we don't really write, but we can make note of it. And that's going to go through. So when I graph, I can go to -2, I can go to +1, I know I'm going to finish degree 3, lead coefficients positive because there's nothing else being multiplied. So I know I'm going to come up towards -2. I'm going to go down this way for sure, up this way for sure. I know that because of the degree. Now, at -2, I'm going to touch and turn around and go the other way, and then I will go through. And it will always work itself out properly like that, where you know what's happening. So for example, what if we had one that was x plus 2 squared, x minus 1 squared, where they're both squared. Now they're going to touch and touch, but now my degree is 4. So how would that look? I'd go to -2, I'd go to +1. I know I'm finishing up and up, but I'm coming down, and I'm going to touch, and I'm going to turn, and I'm going to go down, and I'm going to touch, and I'm going to turn. So it always works itself out nicely. That's all we have for 2.3, so have a great lesson.